the way that I explain this, ladies and gentlemen, is if we're going to go ahead and factor this, all right? We're going to be factoring a trinomial. Now, trinomials has a special factoring technique. If you guys remember last time, we dealt with a binomial, right? And when we had that binomial, we just created a box with our two terms, correct? And we could just factor out our common terms, and that was the same. Well, in this case, you might be tempted to go ahead and do one box with one row here. But the problem with that is, if you guys look at this, if I want to find the height that I can multiply to give me each and every one of those terms, we have an issue with that, right? There's not a height, or at least an integer, or a value that I can multiply to give me each and every one of those, correct? So just multiplying out a greatest common factor in this case is not going to work. So what we're going to want to do in this case is when we're factoring trinomials, if you guys remember when we were multiplying binomials, if you guys remember when I did like x plus 3, x minus 2, when we'd multiply binomials, right, the binomials gave us, when you multiply a binomial times a binomial, the product ended up giving us a trinomial, meaning it has two terms. The reason why was because the middle terms added together. Does that make sense? You guys remember that? When we multiplied, that's why we did that focus lesson. Binomial times a binomial. These middle terms combined to give you your middle term. So therefore, we ended up with a trinomial. So when we're factoring trinomials, if we can't factor out a GCF, meaning a common factor of all three terms, to factor that, we're going to want to look at the area as 4 terms. OK? So that's why I gave you guys those boxes, because this is a little bit of the longer technique. So to do that, basically what we're going to do is we're going to put the first term in the upper left-hand corner and the bottom term in the bottom left-hand corner. Because remember, this represents the area, right? And factoring, we're trying to find the side lengths of the box. So these two always represent the area. However, there's a problem. Remember these middle two terms? They combine to give us that middle term. So we can't put 3x into both of those boxes. We got to find two terms that add up to give us that 3x. Do you guys remember that? Let me go back to this. Our middle terms added to give us this. So we got to figure out what two terms are going to add to give us a positive 3x. So to do that, what I did is I create our c and our b. And if you remember the perfect form of ax squared plus bx plus c. So what I'm going to, yes?
In your example equation to the left, negative.
That should be a positive, right?
Positive.
Thank you. Did I write that on the first one the first time I did it? Or did I switch it around? Do you remember? OK. Anyways, thank you. So all we're simply going to do is we're going to take the value of c, which is -4. And we're going to take our value of b, which is 3. Then I wrote the little dot there, and I wrote the little plus there. And what that means is I want you to figure out what two numbers multiply to give you c, but then add to give you b. Because remember, that 3x is what those terms add to. These two middle terms add to give us our middle term. So we got to figure out what two numbers add to give us a positive 3. Now, when doing that, to figure out what two numbers multiply to give you -4, forget about the negative. Just write down the factors of 4. And that's why we, again, did that focus lesson of factoring. Remember, breaking down a number. And what you guys can, we're not really doing a factor tree, though. You're just breaking down all the factors. Now, if the two numbers multiply to give you -4, but they add to give you positive 3, should the larger factor be negative or the smaller factor? Smaller factor. So I always write the factors for the positive value of c, and then I add in the negative at the end. Now here, these are exactly the same, so I can't put in a negative. So do you guys see how the only answer to this one would be +4 and -1? Does that make sense? OK. So I'll write +4 and -1. But remember that +4 and -1, those are the two terms that add to give you this. So I'm going to write 4x and -x. Do you guys agree with me that if I multiplied and I got this as my answer, that I have x squared, 4x minus x is 3x, and then -4? Does that make sense? That's why we put them with x's in there, because they add up to give you positive 3x. Now, for the factoring part, all you're simply doing is finding the side lengths of each box. So x squared to give our length times width to give us x squared is going to be x times x. So x times what gives us negative x? Negative 1. X times what gives us a positive 4x? Positive 4. So that means this side length times that side length gives us the whole area. So therefore, I can represent that as x plus 4 times x minus 1. So even if you understand factoring,